Hey everyone, we are on week 6 and we're going to talk about nuclear fission. This is a little more touchy topic for me because I'm not really I don't really understand it. It's a little bit more difficult for me to comprehend. I did some research online. I'm gonna read about nuclear fission, show you an image of it, and then did a research on nuclear weapons. So I'll go over that as well. So to start off with, I have, in simplest terms, nuclear fission is the splitting of an atomic bond. Given that it requires great energy to separate two nucleons, it may come as a surprise to learn that splitting a nucleus can release vast potential energy, and although it is true that huge amounts of energy can be released, considerable effort is needed to do so in practice. An unstable atom will naturally decay, but it may take millions of years to do so. As a result, a physical catalyst is necessary to produce useful energy through nuclear fusion. The catalyst typically occurs in the form of free neutron project directly at the nucleus of high mass atoms. So this is going to be the little picture that they had with their definition. There's that. And then I'm going to go on to explain a little bit about what I found out on fusion, because there's fission and then there's fusion. I think I'm saying those right. So fusion works in reverse. When exposed to extreme high temperatures, some slight weight nuclei can fuse together to form heavier nuclei, releasing energy in the process. So fission is the separation of the nuclei, and fusion is them becoming one. So it says in modern nuclear weapons, and I'm sorry I forgot to say this website is ucsusa.org. But as I was saying, in modern nuclear weapons, which use both fission and fusion, a single warhead can release more explosive energy in a fraction of a second than all the weapons used in World War II. Okay. And then here's how it works. All nuclear weapons use fission to generate an explosion. It kind of goes on how the first nuclear weapon was a little boy. It was used during wartime, and it worked by shooting a hollow uranium-235 cylinder at a target plug of the same material. Although here it says modern nuclear weapons work slightly different. Critical mass depends on the density of the material. As the density increases, the critical mass decreases. Instead of colliding two critical pieces of nuclear fuel, modern weapons detonate chemical explosives around the subcritical sphere or pit of uranium-235 or plutonium-239. The force from the blast is directly inward, compressing the pit and bringing its atoms closer together. Once dense enough to reach the critical mass, neutrons are injected, initiating a fission chain reaction and producing an atomic explosion. So from what I can understand from it is basically the explosion is set off by the pressure of the energy of the nucleus. Like I said, this is a little bit more difficult subject. I'm still doing more research on it, but this is all that I have now and all that I'm taking in. But thank you for watching, and I'll see you next time. Thanks.